makes sense. Hi. All right, guys, we're back. Functional decomposition. I have no idea what that means. To be perfectly honest with you, but I'm assuming it's well, decomposition is basically when something decomposes or when you kind of like destructure something, maybe. So like functional decomposition is the destructuring of something. Let's see. Helps manage complexity and reduce uncertainty by breaking down processes, systems, functional areas, or deliverables into the simpler constituent parts. Instead of decomposition, I would have used destructuring, but okay. Allowing each part to be analyzed independently. That makes sense. This connects to the first principles approach of شو اسمه. First principles approach. It's a scientific method where you kind of like dive into the foundational parts and the singular aspects that combine together in order to make the whole. It's a systematic view of the world. So, functional composition approaches analysis of complex systems and concepts by considering them as a set of collaboration or related functions, effects, and components. The isolation helps reduce the complexity of the analysis, breaking down larger components into subcomponents, allowing scaling, tracking, and measuring work effort, or each of them. It also facilitates evaluation of the success of each subcomponent as it relates to larger or smaller components. The depth of decomposition may vary depending on the nature of components. All right, 1 second. So breaking down larger components into subcomponents, allowing scaling and tracking. Okay, we're good. The measuring work effort for each of them, we kind of like, we're kind of like we're breaking down the castle into Lego blocks and the components of the actual like castle. Like this is a room, and 5 rooms make a house, and 5 houses basically make a building, right? Like, okay, I started a castle and I went into buildings. Anyways, like a house has basically like a bathroom, and a bathroom basically has like its own parts, right? And the depth of decomposition may vary depending on the nature of components and objectives. Functional decomposition assumes that subcomponents can and do completely describe the parent component. Any subcomponent can have only one parent component when developing the functional hierarchy. At the beginning, yes, but like if you think about it this way, the same room is built. The different rooms are built using same blocks. So there are some things that might be connected, but maybe decomposition and there's probably a reconstruction somewhere. Then the functional decomposition, is there functional construction or reconstruction? I have no idea. Let's move forward and see maybe my hypothesis. So the diagram below provides an example of how a function can be broken down. So there's a function, and there's a subfunction and subfunction, and there are like different processes, and every process has its own activity, right? Or a process has an activity, or a process has another process and another activity, or whatever it is. What are the elements? Well, what's the objectives? Like, what are we doing? The objective of functional decomposition both drive the process of decomposition and define what to decompose, how to decompose, and how deeply to decompose. I think I mentioned it in one of the videos that we have something called a pure function in programming, and there's a great order function. A pure function is the smallest form of a function. If you give it something, if you always give it the same thing, it always gives you the same result. But a higher order component is basically built around multiple functions doing multiple things, and ultimately like the code is kind of like, just getting a whole lot of information and getting out different information. So depending on what you want, you start with something that's kind of like, okay, this is what I look at, and then you bring it down into the purest of functions. So the objectives may include measuring and managing to isolate specific manageable factors that contribute to the overall result, or to identify important metrics and indicators. There's a designing part to simplify a design problem by reducing the isolating object of design. For example, I'm gonna use code again, but the logic that I'm trying to approach is شو اسمه The logic I'm trying to approach is more of a, like, okay, so like, let's go back to the house. If I want to break down the house into different parts, there's basically the house, and then there's rooms, and then there's walls. Like, do I need to break down the wall into like different chunks of blocks and cement? Probably not, because I can use the same like structure of the wall that basically is applied everywhere around the house. Maybe that is enough. Maybe I need to dive into the block itself, and even the block, how it's built, could be actually like kind of, we can dive deeper into that. So you get to decide basically, like, and that's where the design comes. Like, this is what we want to know. So I want to know how many walls we need, or like how to estimate walls into the future, because like building a wall, when it comes to building construction, what they do is they kind of like, they measure based on meter square of construction, because every meter square of a wall is basically like requires water, cement, blocks, some work, whether it is they're building on top of each other, and whether they're plastering or whether they're painting. Like, every meter square costs X amount, and that's how they estimate buildings and shit like this. So you get it? It's like they didn't go all the way deep into everything, but they did at one point, and based on that, they kind of like don't have to go that deep again. Designing to simplify the design problem by reducing and isolating the object of design. Analyzing to study the essential properties and behaviors of the artifact or phenomena or isolation, because the function, right? Like, what are you looking at? I'm looking at a function that, I'm looking at a wall that I use in order for me to close a space and to build a room. There's estimating and forecasting as well, to decrease the level of uncertainty and breaking down complex value into its constituent factors. There's reusing to create reusable solution building block that serves the service function. The irony, building block, right? And we're talking about a wall, a room. Various processes. There's optimization to detect to alleviate the bottleneck. Like, no, okay. It's like if you go to a place and you're building a room, but this room has about like 20 people enter and leave every fucking minute, then ultimately you need a much bigger door than a small one, right? So like you optimize by kind of like alleviate the bottleneck, make bigger doors. And there's substitution as well to make a specific implementation on a solution component or a function easily replaceable without impacting the system as a whole, right? Encapsulation, combining elements to make one element. The substitution is interesting because you can always like take parts and kind of like exchange them. For example, the wall, does it really need blocks? So like, if we have a big room with like 3-4 walls, but we need to do a partition in the center, we don't necessarily have to do it as a wall. And the same applies to like everything that you're kind of like looking at when it comes to like structure, right? Because some structures are not necessarily that intense, and some other structures need the intensity. So subjects of decomposition, functional decomposition, applies to a wide variety of versatile subjects, such as business outcomes, income, profit, expense, volume, or service. Work to be done, decomposition, known as work breakdown structure, breaks endeavors into phases, milestones, work activities. What do they call? My favorite new word is cycles, like work cycles. A business process to identify its constituent part for the purposes of measuring, managing, optimizing, and reusing the process of its components. There's a function to enable its optimization or implementation, business unit to enable its reverse engineering and design, solution component to enable its design, implementation, or change, activity to enable its implementation, modification, optimization. It's like all that you can decompose everything you decide you want to do, right? You can tear it into pieces, destructure it. I would love the term destruction instead of decompose. Fuck them. Bunch of nerds. All right. Products and services, and ultimately decisions. Like, what decision am I making? Well, the level of decomposition or appropriate level of functional decomposition defines where and why, where to stop decomposing the subject. Like I said, you're looking at a building. Do you want to decompose it into floors, into rooms, into the wall, into the block, into the cement and the sand that's required, right? That's what you want to do. A representation of decomposition results, representations of functional decomposition result allow business analysts to both validate and verify the results and then use them to solve other tasks. The result can be expressed as a combination of plain textual descriptions, hierarchy lists, descriptions using special form. Like, okay, you can do any fucking way you want to represent them. It could be literally in language. So there are tree diagrams, which we've talked about before, hierarchical partitioning of work, activities, or deliverables. Nested diagrams illustrate hierarchical part-to-whole relationships between decomposition results. Use case diagrams represent decomposition on higher level use case. Flow diagrams depict results of a process or function decomposition. A state transition diagram explains the behavior of an object inside its composition state. Cause and effect diagrams elaborate on events. Decision trees, mind maps, component diagrams, and decision model annotation. It feels like these basically tools are kind of like pointing at each other now, right? Like, you know, they're kind of all intertwined, because like in order to do one thing, you kind of have to use other things, and to do other things, you have to use this thing. So decision model annotation to analyze the business logic, component diagram, how components are wired together, mind maps represent information in categories, decision trees detail the structure of a complex decision and its potential outcomes. We've been talking about these for a while, by the way. Usage considerations, strengths, makes complex endeavors possible by break down complex problems into feasible parts. You should do that with everything, by the way. Everything. Every time you start something, every single thing. Go back to point zero. Provides a structured approach to building a shared understanding of complex matters among the diverse group of stakeholders, simplifies measurement and estimation of the amount of work involved in pursuing a course of action, defining scope of work, and defining process metrics. What are the limitations? Missing and incorrect information on time decomposition is performed may later cause a need to revise the results. Many systems cannot fully represent a simple hierarchical relationships, because some systems are very big, so you have to, there are a grouping of smaller systems. So you just build the smaller systems and create the data flow and the actual contextual flow in between them. And then ultimately you have a bigger system, right? Every complex subject allows multiple alternative decompositions, exploring all alternatives. I think here, when they're talking about not fully represented by simple hierarchical relationships, it's because, let's just say there's a company that's connected to a company on the outside world. And what happens is that's a different system that's kind of like contributing to this system. And if that system kind of like falters, then yours kind of like falters. But do you have to decompose that shit, or just the process that you're building on top of? I don't know. Every complex subject allows multiple alternative decompositions. Exploring all alternatives can be a challenging and time-consuming task. While sticking with a single alternative may disregard important opportunities and result in suboptimal solutions, of course. Like, remember, what we're doing here is we're always trying to do the best we could. And in order to do that, we need information. And the problem with that is you can never get enough information. Literally. Your brain processes a whole lot of information every second. Like right now, I'm looking at the computer, I'm seeing words, I'm seeing colors, I'm seeing shapes. All of these are bits of information. Like, all of them are kind of like combined in one thing. But imagine looking at a tree or walking by a car. Like, all of these kind of enter and then leave. That triggered something in me. Forgot, let go. All right. Performing functional decomposition may involve deep knowledge of the subject and extensive collaboration with diverse stakeholders. The reason why this is a limitation is because you need to find them, you need to work with people, and you need to know what the fuck you're doing. Sometimes, right? And depending. All in all, this is amazing. Fuck yeah. Thank you very much, guys. And love. See you on the next one.